Dear student, our lesson today will provide an in-depth discussion of the laws of indices. Numerous examples will be given and exercise questions issued towards the end of the lesson. Welcome. Our specific objectives. By the end of our lesson, the learner should be able to state the laws of indices as well as applying the laws of indices in solving questions. Prerequisite knowledge. The learner should be able to carry out addition and subtraction, multiplication and division, as well as understand the concept behind powers and roots. For the learner to be able to understand the concepts discussed herein. The laws of indices form a basis of understanding many concepts in higher learning institutions, for example, in the computing sector, engineering, medicine, etc. Indices are also a crucial part of the global investment business. Indices are used to show numbers that have been multiplied by themselves or to represent roots like square roots, cube roots, fourth roots, etc. Generally, if n is a positive integer, a power n means a multiplied by itself n times. Laws of indices. Let us consider the following. 1. A power 3 times a squared. This is the same as a times a times a, that gives us a power 3, then times a times a, which is a squared. This can be expanded to give us a times a times a times a times a. We can clearly see that a has been multiplied by itself 5 times. Therefore, it can be written in simple terms as a power 5, where 5 is the power and a is the base. Comparing the original expression, that is a power 3 times a power 2, with the expression that we have, a power 5, we clearly see that to get a power 5, we have simply added the powers. That is a raised to power 3 plus 2. So that is the sum of powers. This implies that in general sense, if you have a power m times a power n, it is the same as a raised to power m plus n. This gives us our first law of indices. Examples. 1. Evaluate 2 power 5 times 2 power 4. According to our first law of indices, we are going to add the powers and take 2 as our common base. So 2 power 5 times 2 power 4 equals to 2, which is our common base, power 5 plus 4. 5 plus 4 is 9, so this becomes 2 power 9. 2 power 9 means 2 multiplied by itself 9 times, and this gives us 512. Example 2. Evaluate 3 power 2 times 3 power 3. So this can be expressed as 3 raised to 2 plus 3, which becomes 3 power 5. 3 power 5 means 3 times 3, 5 times, which gives us 243. Example 3, evaluate 2 power 7 times 2 power negative 2. According to the law of indices, that is, according to our first law, 2 power 7 times 2 power negative 2 is the same as 2 raised to power 7 plus negative 2. 7 plus negative 2 is the same as 7 minus 2, which is 5, and so we write 2 power 5. 2 power 5 is the same as 2 multiplied by itself 5 times, and this becomes 32. Let's consider a second case, that is a power 3 divided by a power 2. This is the same as a times a times a all over a times a. Since we can see that some items in the numerator and the denominator are the same, we can cancel them out as follows. A cancels with a, and then this a cancels with this a. What is left is simply a. This a is the same as a power 1. Comparing the powers, we clearly see that a power 1 is the same as a power 3 minus 2. This is simply the difference of the powers. Therefore, this implies that if you are given a general sense, that is a case like a power m divided by a power n, this is the same as a, which is our common base, raised to m minus n. This is our second law of indices. Let's look at some few examples. 1. Evaluate 2 power 5 divided by 2 power 4. According to our second law of indices, we take a common base, which is 2, and subtract the powers, and so this becomes 2 power 5 minus 4, which is 2 power 1, and 2 power 1 is simply 2. Second example, evaluate 3 power 5 divided by 3 power 3. 3 power 5 divided by 3 power 3 is the same as 3 power 5 minus 3, which is 3 power 2. 3 power 2 means 3 times 3, which is 9. Example 3. Evaluate 2 power 3 divided by 2 power negative 2. This is the same as 2 raised to 3 minus negative 2. 3 minus negative 2 is the same as 3 plus 2, which is 5. So we write 2 power 5, which means 2 multiplied by itself 5 times, giving us 32. Let's consider another case, that is a power 3 raised to power 2. This can be expressed as a power 3 times a power 3. Expanding this, we get a times a times a, then times a times a times a. Once we expand this, we get a multiplied by itself 6 times, which can be written as a power 6. A power 6 is the same as a power 3 times 2. So if we consider the powers originally that we had, it is the same as having 3 times 2, which gives us 6. This is what we call the product of powers. It therefore implies that if you have a power m, then raised to power n it is equal to a power m times n, which is written as a power mn. This is therefore our third law of indices. Let's look at some examples. 1. Evaluate 2 power 5 raised to power 2. So this is the same as 2 power 5 times 2. 5 times 2 is 10. So this becomes 2 power 10. 2 power 10 means 2 multiplied by 2 10 times, and this becomes 1024. Our second example, evaluate 3 squared power 3. So according to our third law, this is the same as 3 raised to power 2 times 3, which is 3 power 6, which therefore narrows to 729. Example 3, evaluate 2 power negative 3, everything raised to power negative 2. So this is the same as 2 raised to negative 3 times negative 2. Negative 3 times negative 2 is positive 6. So this becomes 2 power 6, which means 2 multiplied by 2 6 times, which gives us 64. Let's now take note that for the 3 laws to hold, the base must be the same, and that is what we call common base. The zero index. Let's consider the expression a power n divided by a power n. This is the same as a power n all over a power n. We can now cancel out the numerator to give us 1 and the denominator to give us 1. 1 divided by 1 is the same as 1. Now, using the second law of indices, we have a power n divided by a power n, which is equal to a power n minus n. Since n minus n is 0, we therefore can have a power 0. Comparing a power n divided by a power n equals to 1 and a power n divided by a power n equals to 0, we can therefore clearly see that a power 0 equals to 1. And this gives rise to what we call the zero index or the zero power. Examples. 1. Evaluate 2 power 0. 2 power 0 is equal to 1. In short, every non-zero number raised to 0 is equal to 1. Example 2. Evaluate 25 power 0. 25 power 0 is equal to 1. Example 3. Evaluate 63 power 0. This is simply 1. Example 4. Evaluate 2 power 5 divided by 2 power 5. Using our second law, we have 2 power 5 divided by 2 power 5 equals to 2 power 5 minus 5. 5 minus 5 is 0, and so this becomes 2 power 0. 2 power 0 is simply 1. Example 5. Evaluate 2 power 5 times 2 power negative 5. Now in this we are going to use our first law of indices, whereby we are going to take the common base and get the sum of the powers as follows. So we have 2 power 5 plus negative 5. 5 plus negative 5 is the same as 5 minus 5, which is 0. So we have 2 power 0, which is equal to 1. Basically, any non-zero number raised to power 0 is 1. The negative indices. Let's consider the expression a power negative n times a power n. Using the first law of indices, whereby we sum the powers, we will have a power negative n times a power n equals to a power negative n plus n is 0. So we have a power 0. Since a power n times a power n, since a power negative n times a power n is equal to 0, it means that making a power negative n the subject, it becomes a power negative n equals to a power 0 divided by a power n. But a power 0 is equal to 1. So a power negative n is equal to 1 over a power n. This is now what we call the negative index. Examples. 1. Evaluate 2 power negative 3. According to the negative index, we are going to take the reciprocal of 2, which is 1 over 2, and then raise to power positive 3. So this gives us 1 over 2 power 3, and 2 power 3 is the same as 2 times 2 times 2, which gives us 8. So this becomes 1 over 8. Example 2. Evaluate 3 over 2 raised to power negative 2. So 3 over 2 raised to power negative 2 is the same as, now we are going to take the reciprocal of 3 over 2, which becomes 2 over 3, then raised to power positive 2. This is the same as 2 power 2, which is 4, and then 3 power 2, which is 9. So our answer is 4 over 9. The fractional indices. Consider the number 4 power half. 4 power half times 4 power half is the same as 4 power half plus half. This is according to our first law of indices. A half plus a half is 1, and so this is the same as 4 power 1, which is simply 4. This means that 4 power half times 4 power half is equal to 2 times 2, since 4 is the same as 2 times 2. So this implies that 4 power half is equal to 2. And so 4 power half is also the same as the square root of 4, which is 2. Therefore, 4 power half is simply the square root of 4. Similarly, 4 power a third times 4 power a third times 4 power a third is the same as 4 power a third plus a third plus a third. This is according to our first law of indices. A third plus a third plus a third is 1. So this is the same as 4 power 1, which is simply 4. Therefore, 4 power a third is equal to the cube root of 4. In general, a power 1 over n is now the same as the nth root of a, and this is the fractional index. N must not be 0 for this case to be true. An important note: suppose we have a power m over n. This is now the same as the nth root of a raised to power m. Examples: 1. Simplify 25 power a half. According to the fractional index, 25 power a half is the same as the square root of 25, which is 5. Example 2. Simplify 32 power 1 over 5. According to the fractional index, this is the same as the fifth root of 32. The fifth root of 32 is simply 2. Example 3. Simplify 81 power 3 over 4. 81 power 3 over 4 is the same as the fourth root of 81 raised to power 3. The fourth root of 81 is 3, so 3 raised to power 3, this becomes 27. Some practice questions. 1. Solve 4 power x raised to power 3. This is equal to 64. We want to get the value of x in this question. So we are going to multiply the powers. So we have 4 power 3x being equal to 64. 64 can be expressed to base of 4, and this is 4 power 3. So we have 4 power 3x equals to 4 power 3. It is now easy to see that the bases are the same. Therefore, the powers must also be the same. So this means that 3x equals to 3. Dividing both sides by 3, we have x equals to 1. And therefore, that is the value of x. Question 2. Find the numerical value of 36 raised to negative a half. We can see that here we have a combination of laws of indices, beginning with the negative index and the fractional index. Let's solve this. This is the same as, now using the fractional index, 36 power a half means the square root of 36. But whenever we have a negative power, it means taking the reciprocal and the power becomes positive. So we have 1 over the square root of 36. Square root of 36 is 6. So this simplifies to 1 over 6, which becomes our answer. Question 3. Find the numerical value of 10 power 3 raised to power 5 over 3. 10 power 3 raised to power 5 over 3 is the same as 10 into 3 times 5 over 3. 3 times 5 over 3 simplifies to 5, and so this becomes 10 power 5. 10 power 5 means 10 times 10 5 times, which becomes 100,000. So that is the numerical value. Question 4. Simplify the expression 27 power a third times 9 power a half. Since the bases are not the same here, there is no way we can add the powers, but we can see 27 and 9 are both products of 3. So they can both be expressed in terms of 3 so that the base is common. So this is the same as 27 is the same as 3 power 3. So we have 3 power 3 into 1 over 3 times 9, which is the same as 3 squared. So 3 power 2 then into a half. Expanding this, 3 into a third is the same as 1, and then 2 into a half is the same as 1. So this simplifies to 3 power 1 times 3 power 1, which becomes 3 power 2 according to our first law of indices, which states that if numbers have the same base and have been multiplied, we sum up the powers. So 1 plus 1 is 2. Therefore, 3 power 2 is 9. Question 5. Simplify 5 over 6 raised to power negative 2 times 6 over 5 raised to power negative 2. This expression is the same as 6 over 5 squared times 6 over 5 power negative 2. We can see that we have taken the reciprocal of the first part since the power was negative. And so the bases are now the same. So we are going to take the common base and then we sum up the powers. So 6 over 5 raised to power 2 plus negative 2. 2 plus negative 2 is the same as 2 minus 2, and so this is 0. 6 over 5 raised to power 0 is simply 1. Question 6. Simplify 12a power 5b power 3 all over 3a power 3b. We can see that we have common terms between the numerator and the denominator, which can be simplified by cancellation or simply applying the laws of indices. This becomes 12 divided by 3 is 4, but then we have a power 5 divided by a power 3, which means we take a common base, which is a, and subtract the powers. So 5 minus 3. Then b raised to power 3 minus 1. This becomes 4a squared b squared. Question 7. Simplify 4 power 5x divided by 2 power 3x squared equals to 256. So in this case, it is possible to get the value of x by applying the laws of indices. First, we express 4 to base of 2, and we also express 256 to base of 2. Therefore, 4 is the same as 2 squared, but we remember it is to power 5x, then divided by 2, raised to power 3x times 2, which is 6x, equals to 256, which is 2 power 8. This is the same as 2 power 10x. Then according to the second law, we subtract the power. So 10x minus 6x equals to 2 power 8. Since the bases are the same, it therefore follows that the powers must be the same. So 2 power 4x equals to 2 power 8, which means that 4x equals to 8. Dividing both sides by 4 gives us the value of x being equal to 2. Exercise questions. 1. Simplify each of the following expressions. You may leave your answer in index form. A. 3 cubed times 3 power 4. B. 512 power 2 over 3 times 8 power 1 over 3 divided by 2 power 6. C. B cubed times n squared times b power 0 times n cubed. D. A power 4b cubed times a squared c power 4 times b power negative 2c cubed all over a power negative 3 b cubed c cubed. Question 2. Find the numerical value of 64 raised to power negative 1 over 6. 3. Find the value of x if 27 over 8 raised to power x plus 7 equals to 4 over 9 raised to power negative 3. Question 4. Evaluate the value of x in the expression x power x raised to x equals to 1. 5. Find two possible values of x given that x power x raised to x equals to x. 6. Solve for x given that 5 power 2x minus 1 all over 25 equals to 125 power x.